Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a program dedicated to fundamental econometric concepts, estimation methods, and identification strategies. We have learned how to compute the robust t statistics for an individual variable and the robust f statistic for the joint significance of multiple variables when the variance of the error term is not constant. Today, we will explore a third test, the robust LM test, that is robust to the heteroskedasticity of an unknown form. They serve the same purpose as the F statistics, but we can manually compute the robust LM statistics from the restricted model and the auxiliary regression. The name of the test, LM, is the abbreviation for Lagrange multiplier. There are standard procedures we can follow to conduct a robust LM test. Let me explain using the same example as in the previous topic. This model associates workers' hourly wages with their years of education, ages, number of children, gender, marital status, health status, region of residence, and race. Suppose we want to know whether there is no difference in hourly wage across regions after controlling for other factors. The null hypothesis is that the parameters of the 4 region dummy variables are all 0. By the way, the methods of transforming one categorical variable into several dummy variables in Stata can be found in my other teaching videos. Here, the region variable has 5 categories: northeast, north central, south, west, and other. I treat the first category, northeast, as the base group and use 4 dummy variables to denote the other 4 categories of region. The coefficient of each region dummy is the difference in hourly wage between that region and the base region of the northeast. The null hypothesis is that the coefficients of the 4 region dummy variables are all 0. In the previous topic, we employed the robust F test for the joint significance of the region dummies. Now we use the LM test. It involves the restricted model only. We know that the unrestricted model is the original model with 16 explanatory variables. The restricted model is the model under the restriction of the null hypothesis. That is, the coefficients of the 4 region dummy variables are 0. So the restricted model is shorter with 12 explanatory variables. There are 4 steps to perform the robust LM test. In the first step, we obtain the residuals, mu tilde, from the restricted model. In Stata software, The predict command with the residuals option stores the residuals in a new variable. I name it mu tilde. Notice that the regressions in the LM test are the usual OLS regressions without any robust modification. In the second step, we regress each of the explanatory variables excluded from the model under the null hypothesis on all the included explanatory variables. In our example, we have 4 excluded dummy variables that are excluded from the model under the null hypothesis. So we have 4 regressions. To create the 4 dummy region variables from a categorical variable, we use Stata's tabulate command with the generate option. It generates 5 region dummy variables. We only use 4 in the model to avoid the dummy variable trap. I treat the first region, the northeast, as the base group. After regressing each of the 4 region dummies on all included variables, we store the residuals from each regression. I name them from R1 tilde to R4 tilde. In the third step, we generate 4 new variables equal to the products of each R tilde and mu tilde. In the fourth step, we run an auxiliary regression without an intercept. That is the regression of 1 on 4 new variables we just created. The outcome variable y has the value 1 for all observations. We regress y on the 4 products using the option no constant. The robust LM statistic equals n times SSR, where n is the sample size and SSR is the usual residual sum of squares from this regression. Under the null hypothesis, the LM statistic follows a chi-square distribution. In our example, the robust LM statistic equals 25.68. Its p-value is 0 to 4 decimal places. We reject the null hypothesis and conclude that there is a difference in hourly wage across regions after controlling for other factors. We can compare the robust LM statistic with the usual LM statistic. Recall that the usual LM test can be done in 2 steps. In the first step, we regress the restricted model and obtain the residuals. In the second step, we run the auxiliary regression of the residuals on all explanatory variables, including both excluded and included variables. The usual LM statistic equals the sample size times the residual sum of squares from the auxiliary regression. the usual LM statistic is 25.99, slightly higher than the robust LM statistic. We reject the null hypothesis according to either the robust or the usual LM test. The idea behind the LM test is that the residuals from the restricted model contain variation that cannot be explained by the included explanatory variables. If the excluded variables are highly correlated with those residuals, we can reject the null hypothesis and should not exclude those variables from the model. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.